All right, so the first one says the rate of rainfall accumulation in inches per hour is a function of the time since the rain began. Data from a recent storm are shown in the table. So I have the accumulation rate. So the question is, I want to do a right-hand Riemann sum for the given data. So if I do a right-hand Riemann sum, I look at the first interval, I'm going to pick the data point on the right. So it'll be 1 times 0.6 plus. For the next 2-hour period, I'm going to use this. So I'll have 2 times 0.4 plus. For the next 2-hour, it's a 3-hour period, I'm going to use the 0.1. 3 times 0.1. So this is the time length of the interval. So the delta time, and then this is the rate. Right, so if we do the rate times time, that should give us the total amount of rainfall. So let's add that all up. So 1 times 0.6 plus 2 times 0.4 plus 3 times 0.1. So you get 1.7. And so what are the units of that? Well, if I think about what I've done is I've multiplied time times hours, and then this is inches per hour. So this is inches. So is an approximation of the total amount of rainfall in inches. So the correct answer is A. Okay, this graph is used for parts 6 and 7. Oh, this might be tricky. So on the other side, it asks for the value of A of 4. So to compute, let's see. So that would be from here to 4. So I need to just compute that area using geometry. So I can see I've got a rectangle here of, so 2 times 4 plus, negative 4. And then I have a triangle here, so it's 1/2. The base is 2. The height is negative 4. And then this little triangle, the base is 1. And the height is 2. So if I add that all up, negative 4 times 2 plus negative 4 plus, that'll end up being 1. So I got negative 11. Okay, so for the next one, I'm asked to compute A prime of 1. So if A of x is equal to the integral from negative 1 to x of f of t dt, by the fundamental theorem of calculus part 2, A prime of x is equal to f of x. So A prime of 1 will be f of 1, and f of 1 is negative 4. So it says, consider the area function using the graph. Compute the value of A of 4. Area function starts at negative 1. So for my work on the previous page, the answer is negative 11. Compute A prime of 1. So for my work on the previous page, the correct answer is negative 4. So A prime of x will be the derivative with respect to x of the integral from negative 1 to x f of t dt, which is equal to f of x by the fundamental theorem of calculus part 2. Next says compute the following integrals. So if I want to compute an antiderivative of that, I will end up with x to the 6th, and then I'll have 4 over 6 minus 3/2 x squared plus c. For the next one, an antiderivative of cosine is sine of x plus, and I'll have pi times x plus c. For the next one, I want to do an antiderivative of e to the x will just be e to the x. I evaluated from 0 to 1, so it'll be e to the 1 minus e to the 0. So this will be e minus 1. For the next one, I know that an antiderivative of 1 over x is natural log of absolute value of x. I want to evaluate that from 2 to 5. So I'll have natural log absolute value of 5 minus natural log absolute value of 2. Next, I need to evaluate each of the following. So this one is going to utilize u substitution. So I can let u equal y to the 6th minus 4. Then du is going to be 6y to the 5th dy. So I need a 1/6 on the outside and a 6 on the inside. So I'll have square root of y to the 6th minus 4 times 6y to the 5th dy. So because I multiplied by this 1/6 out here and this 6 in here, I'll make them a different color so I can see it. So the only thing I did here is I multiplied by 1/6 and 6, which is basically like multiplying by 1. So I haven't changed the integral. Now I'm ready to do my substitution. So I'll have 1/6 integral of u to the 1/2 du. And so if I integrate that, I will get 1/6 times, I'll have u to the 1/2 plus 1, so 3/2 times 2/3 plus c. So this will give me 1/9 times my u, which is y to the 6th minus 4 plus c. All right, for this next one, I'm going to let my u equal natural log of x. Then my du is 1 over x dx. So I can rewrite this integral to be natural log of x to the 9th times 1 over x dx. So I can see that that is my du. So I can go ahead and do my substitution. Integral of u to the 9th du. And if I find an antiderivative of that, I'll have 1/10 u to the 10th plus c, which is 1/10 times natural log of x to the 10th plus c. For this one, I'm going to use the fundamental theorem of calculus part 2 combined with the chain rule. So I notice that I have a function up here, a function of x in the bound. So the derivative of this is going to be cotangent of natural log of x squared times 2x. So I have to multiply by the derivative of the inside function. Okay, on this last one, I have a u substitution with bounds. So I'm going to let my u equal x squared minus 1. My du will be 2x dx. So I can pull a 6 out of that. I'll have x squared minus 1 to the 5th times 2x dx. So that should be equal to this over here. My bounds are from 1 to 4. So I'm ready to do my substitution. Well, when x equals 1, what is u? So I can plug 1 into there. So I can say for x equals 1, I'll have u equals 1 squared minus 1, so u is 0. When x equals 4, what is u? u is 4 squared minus 1, which is 16 minus 1, which is 15. So I'll have the integral, 6 times the integral from 0 to 15 of u to the 5th du. And then I can find an antiderivative of that. So I'll get 6 times 1/6 u to the 5th. I'm going to evaluate that from 0 to 15. So this will be 15 to the 5th minus 0 to the 5th. So that will give me 15 to the 5th, whatever that is. All right, so for the next one, I'm told that the integral from a to b of g of x is equal to 4a plus b. And then I'm asked to find the integral from a to b of g of x plus 7. So we can just say the integral from a to b of g of x plus 7 is equal to, dx, is equal to the integral from a to b of g of x dx plus the integral from a to b of 7 dx. I already know a value for this one. I'm given it. This is 4a plus b. And this one will be, I can think of this as the integral from a to b of just a constant function at 7. So it's just going to be a rectangle. So the width is b minus a and the height is 7. And if I simplify that, I'll have 8b and 4a minus 7a, so negative 3a plus 8b. So the correct answer is C. Okay, evaluate each of the following integrals. So I just need to find an antiderivative of each of these. So I'll have x to the 8th and then divide by the new power. Minus 16 natural log of x plus c. For this one, I'm going to let u equal t cubed. So du is 3t squared dt. So I need to introduce a 3 on the inside and a 1/3 on the outside. So I'll have 1/3 integral of cosine of t cubed times 3t squared dt. So this is, I'm ready to do my u substitution, cosine of u du. So an antiderivative of cosine is sine. And if I go back to my t's, I get 1/3 sine of t cubed plus c. For the next one, I want to utilize the fundamental theorem of calculus part 2 combined with the chain rule. So this will equal sine of 2x squared times the derivative of the inside function, which is just 2. For this one, let's see here. So if I let u equal square root of x, which is x to the 1/2, du would be would be 1/2 x to the negative 1/2. So I almost have that. I need to introduce a 1/2 in here and a 2 on the outside. So I'll have 2 times the integral from 1 to 4 of 5 to the square root of x times 1/2 x to the negative 1/2 dx. So now I'm ready to do my u substitution. So it'll be 2 integral of 5 to the u du. And when x equals 1, u equals 1. And when x equals 4, u equals square root of 4, which is just 2. So this, so an antiderivative of 5 to the u, let's see, what will that be? It'll be 2 times 5 to the u divided by natural log of 5 plus c. So it'll be 2, sorry, not plus c, evaluated from 1 to 2. So it'll be 2 times 5 squared over natural log 5 minus 2 times 5 to the first over natural log 5. So that's my final answer. For the next one, it says the velocity in meters per second of a car t seconds after passing a crosswalk is given by that. Compute the car's distance from the crosswalk 5 seconds after the car passed. So I want to compute the car's distance. So I would need to figure out the position. So I know that the position is going to be the integral of the velocity. So I'm going to integrate from 0 to 5 seconds. So 5 of 1/4, sorry, I can't read that, 3/4 t squared minus 4t plus 6 dt. So an antiderivative of that will be 3 over 4 times 1/3 t cubed minus 4 over 2 t squared plus 6t, and I'm going to evaluate that from 0 to 5. So if I plug in 5, I'll have 1/4, if I reduce that, 5 cubed minus 2 times 5 squared plus 6 times 5. So, and then minus all the rest of that's going to be 0. So I can compute that and get a number value for that. Okay, so the next one, it says the population of a small town changes at that rate. So for this one, we're given the population changes at this rate, and so we're given a rate function for the rate of change of the population. And then it says, write but do not evaluate a left-hand Riemann sum with 10 rectangles using summation notation over the interval from 4 to 9. So if I'm thinking about this interval from 4, so I'm working on part A here. So I go from 4 to 9, and I want to break that up into 10 equal pieces. So I'm breaking that into 10 equal pieces. So in total, that distance is 9 minus 4, which is 5, divided into 10 equal pieces. So my delta x will be equal to 5 over 10, which is 1/2. And then I'll be finding the heights of the rectangle by plugging in the left-hand side. So for the first rectangle, so whatever my function is, I don't know, I'm going to plug in the left-hand side and use that to evaluate the height of my first rectangle. Oh, sorry, that was the right-hand side. I'm going to plug in the left-hand side. So that's this side to evaluate my first one. So my first rectangle will be r of 4 times 1/2. So r of 4 is the height of the rectangle, and the width of the rectangle is 1/2, and so that is my first rectangle. The next one is going to be 1/2 times r of, so for this one I'm going to do 4.5, so 4.5. So I can write that as 4 plus 1/2 times 1. The next one's going to be 1/2 r of 4 plus, I'm going to scooch over by 1/2 2 times. So 1/2 times 2, and I'm going to keep going. For the very last one, I'm going to use the left-hand side to determine the height. So the very last one will be 1/2 r of 4 plus 1/2 times, well, it'll be 10 minus 1, so it'll be 9, 1/2 times 9. And so if I work that out, what is that? That is going to be 9/2, so it's 4 plus 4.5, so that'll be 8.5. So that's what I want. So if I write this in summation notation, I'm summing. The 1/2 is in every single term there. So I'll have 1/2 r of, and the 4 is the same in each one, plus 1/2 times, the thing that's changing in each one is this number of times I'm adding a half. So it's going to be 1/2 times I. And I want to add that from I equals 0 to 10 to 9. 0 to 9. 10 minus 1, so 0 to 9. So that's the way you would write that left-hand Riemann sum in summation notation. Okay, this one says, write but do not evaluate the definite integral whose value is approximated by this sum. So again, we can notice that my sum starts at 5. There are 40 rectangles. So it's starting at 5. We have 40 rectangles. And so when I put in the 40th rectangle, that's going to be 40 divided by 20. So that gives me 2. So when I put in the 39th value here, I'm going to get 5 plus 39 over 20. So it's really close to 7. So it's really 5 to 7, because it's 5 plus 2, essentially. This is a left-hand Riemann sum with 40 rectangles, and the number of rectangles is 40. So each rectangle is 1/20th. So this is going to be the integral from 5 to 7 of r of t dt. Explain what the definite integral you wrote in part B represents in the context of the town's population. So the integral from 5 to 7 r of t dt is the net change in the population from t equal 5 to t equal 7 years. So it's telling you how the population is changing over that 2-year period. Okay, the next one says, this is my integral, -1 to x of f of t dt. Suppose that the limit as x approaches a and from the right and left exist but are not equal. If the limit of a exists, which could be the graph? Okay. So the first thing is that we have that the limit, right and left hand limit exist but are not equal. So D is out because the left and right hand limits are equal. So D is out. B is out because the left and right hand limits are equal. And E is out because the left and right hand limits are equal. Okay, at A, the left and right hand limits are both going to infinity, so you could maybe say those limits exist. If the limit as x approaches a of x exists, which of the following could be the graph? Okay, so if I think about part A, so I've got this negative area, and then it's going to switch up and I'm going to add positive area to it. So I think A is probably the best answer here. I'm not sure. So as x approaches A from the right and left, I need that limit to exist. So I guess the thing is with this one, we're not sure, because this is going off to infinity, we're not sure if this is a infinite or finite area as it keeps going off. So we need kind of more information about graph C to know what's going on with that, with those asymptotes. I think graph A would be the best answer here. Oil leaks out of a tank at a rate. So I'm given a rate where T is measured in minutes. Which of the following expressions represent the exact amount of oil that leaked out from 15 to 45 minutes? Okay, so we're given a rate of change of the oil leaking out, and I'm asked to find the exact amount of oil that leaked out. So this one should be, the second one should be the kind of the obvious answer. That will be the difference in the rates, so that won't work. On the third one, that looks like a Riemann sum with 60 rectangles. So that's going to be an approximation of it, not an exact number. And then this one is an approximation, but the n is going to infinity. So that one looks promising. Let's make sure the numbers are all correct. So this one is starting at 15, and we're adding on rectangles until we get to n. When I add on the n, I'll have 30. So I'll have 15 plus 30k over, 30n over n. So 15 plus 30 is 45. So that'll work. Okay. So yeah, so that'll work. So it's 2 and 4 only. Okay, so for the next one, I'm asked for the derivative of h. Okay, so this is the fundamental theorem of calculus part 2 with chain rule. So it's going to be f of h of x times h prime of x. So that's part A.